move on to solution to question C, which says that write the Taylor series expansion for the function f of x equals to x cos 3x. So moving on, question C says write the Taylor series for the function f of x equals to x cos 3x. So this is a composite function, and a composite function is simply a combination of two or more functions. And here we have a linear function which is x and a trigonometric function which is cos 3x. So you need to know this. First of all, what does your composite function, what is it made up of? Because if you know these different functions, you can easily compute the Taylor series expansion. So we know from the Taylor series function formula, right, is simply f of x equals to f of 0 plus f prime of 0 x all over 1 factorial. So generally it's 0 factorial here plus f double prime of 0 x squared all over 2 factorial plus f triple prime of 0 x cube all over 3 factorial, and so on. That's what we need to take note of. Now from here we see that we have to compute the first derivative, second derivative, and third derivative. There are two ways in which you can do this. From your composite function, this function f of x equals to x cos 3x, you can break this down into the product of its individual functions. So this f of x can be g of x and h of x. So meaning our g of x is x and our h of x is cos 3x. Now what is important here is you can consider them individually. So you take g of x to be x and you take h of x to be cos 3x. You compute the Taylor series expansion of x, which is very easy. You put it in, you insert it in your Taylor series function. You take the derivative, and also you look for the Taylor series expansion of this, you insert it in your Taylor series, and at the end you multiply the two Taylor series expansion. You're going to get your result, which will be our f of x. Now this method is clearly very long, but you are very safe that your solution is going to be correct and you can't make any mistakes. If you're not familiar with the product rule or the quotient rule and all of that, this is what you should definitely do. In this tutorial, we're simply going to look at just computing it using the product rule. Now the product rule states that if you have a function, let's say f of x to be equal to uv, then f prime of x will simply be u v prime plus vu prime. So you consider one function, you differentiate the other, plus you consider the other function, you differentiate the one function, or you differentiate the other. So you take one constant, you differentiate the other, you take the other one constant, you differentiate the other. That's simply the rule. And you need to know, if you have a function, let's say f of x to be cos x, right, f prime of x will simply be negative sine x. If you have a function, let's say f of x to be equals to sine x, then f prime of x will simply be cos x, and the reverse is true for integration. Now if you have a function f of x equals to cos of g of x, now this is different because you have a function here as the angle, right? So the derivative of our x will simply be, remember that when you're differentiating you multiply, when you're integrating you divide. That's usually the rule I take when computing. So in this case, what you have is f prime of x equals to cos of g of x. So the first thing you need to do is you look for the derivative of your angle. So it will be g prime of x, you multiply it, right, with our derivative of our function. So you look for the derivative of this function of our angle, then the derivative of cos is minus sine, right, minus sine of g of x, you maintain the angle. So you have to take note of this. So if you have your function f of x to be equal to sine of g of x, then our f prime of x will simply be the derivative of g of x is g prime of x, then the derivative of sine is cos, then you maintain your angle. This is extremely helpful, and we are going to see how applicable it is in our solution. So in this case, what we have here, we're C. So we are going to look for the first derivative of our function, of this function. We look for the second derivative. We look for the third derivative. I will simply substitute. Again, what I want you to pay attention is the approach, right, of these solutions, not necessarily the answers themselves. So to look for the first derivative of our function above here, we're simply going to have, we take x constant, we differentiate cos 3x. Now 3x is our angle, right? So we are, in this case, we are here, and 3x is our angle. What do? We differentiate 3x. We're going to have 3, right? Then differentiating cos, we have minus sine 3x. So that's the differential. Plus, since it's a product rule, and why are we using the product rule? Because this is a composite function made up of two functions, which is x and cos 3x. Plus, we kept x constant initially, so now we're going to keep cos 3x constant, and the derivative of x is simply 1. So differentiating x with respect to x is 1. I'm sure that is clear. So in this case, we're going to look for our f prime of 0. We simply put 0 here. We're going to have, inserting 0 here, we're going to have cos 0, which is 1. So our first derivative is 1. We're going to move on, looking for the second derivative. So the second derivative is the first derivative of the second derivative, or the derivative twice of the first function. Now I don't want to confuse you with that, but just making it to be clear what I actually do. So if you take the derivative of this function here, you're going to have a second derivative. So just to simplify this, we can rewrite this as negative 3x sine 3x plus cos 3x. Now we are differentiating this function. It will give us our second derivative. So we consider this again. This is a product, right? And we can consider this negative 3 as a constant, meaning that we'll not even pay attention to it, just factor it out and focus on x sine x. We notice again we have our function here, right? Product, which is something similar to what we have above here. So in this case, we're going to keep x constant. We differentiate sine 3x, where in this case, so this will simply be the derivative of 3x is 3, and the derivative of sine is cos, and we maintain the angle, right? Then we keep sine 3x constant, so plus sine 3x constant. Differentiating x, we're going to have sine 3x constant. Differentiating x here, we're going to have 1. Then plus okay, so this will be here. Then plus the derivative of this is minus 3 sine 3x from above. I explained above what I did here. So we're in this case, so it will be negative 3. The derivative of the angle is 3, and the derivative of cos is sine 3x. So that's it. So we can further simplify this as minus 3x, well, it's 3 times 3, which is 9, cos 3x minus 3 sine 3x, then minus 3 sine 3x. So in this case, we're going to have minus 9x cos 3x minus 6 sine 3x. Great. So that's the second derivative of our function, and this implies that our second derivative of 0 will simply be 0, right? Because if we insert 0 here, we're going to have 0 multiplied by 1 is 0, minus 6 sine of 0 is 0. So our second derivative is 0. Now we're going to take the derivative of our second derivative, which will give us the third derivative. So our third derivative will simply be the derivative of this. So again, we factor out negative 9 as a constant, because it's a constant, and the derivative will always be constant. So we have x cos 3x. What do we notice? This x cos 3x is the same as our f of x above here. This x cos 3x is the same as our f of x above here, right? And we saw that the derivative of this function gave us this. So you don't need to compute it, you just copy this down. That's the beauty of mathematics. So it will be 3x sine 3x plus cos 3x. So I've already taken the derivative of x cos 3x from above. Now negative 6 will factor out negative sine 3x. Again, we're in this condition, right? We're here. So the derivative will simply be 3 cos 3x. And we simplify our result. Simplifying this, that is, well, inserting our 0, we're going to have 0 here, 1 here, so it will be negative 9, and here will be 1, negative 6 minus multiplied by 3, I think that is negative 18, minus 18, we take 2 and add here, becomes 20, and we are left with 7, so minus 27. Is that correct? Yeah. So that's it. So what we need to do is simply substitute this in our Taylor series expansion, and that's the solution. As easy as that. So to substitute that in our Taylor series expansion, we're simply going to have our f of x will simply be our f prime of 0. We already saw that f prime of 0 was 1, so it will simply be 1 plus our first derivative. The first derivative was 1 multiplied by x will simply be x, and the second derivative was 0, and the third derivative was negative 27. So plus 0 minus 27 x cubed all over 3 factorial, and you can further simplify. 3 factorial is the same as 3 times 2, which is 6, so you can write this as 6. So this is your Taylor series expansion. In some questions you might be told how long you need to expand. They might tell you to expand to the 5th power or to the 4th power, whatsoever, right? You just need to respect the ones it is not stated. It's generally advisable to get the first 3 known 0 times, like in this case. So that's the solution. So see you guys in the next one.